My name is Chris Reed. I'm a technical fellow for the Boeing Company. And essentially, what that means is you are in a very small, specific community, specifically designed around strategy. So, technical fellowship for Boeing Company is around 1% of the total population of the company. And they represent a diverse set of STEM fields, science, technology, engineering, math fields. For me in particular, I sit in human factors and ergonomics and wearable technologies, hence exoskeletons. And so that's why I'm a technical fellow in that field. Exoskeletons are essentially what they sound like. If we compare it to the animal kingdom, they're essentially the shells of creatures. It's their protective device. Like how we have endoskeletons that support our musculature, they have an exoskeleton to support their body. In this case, exoskeletons for people are similar in fashion. So it's a rigid or a soft set of devices, and it's essentially an exoskeleton, which is tends to be on the harder side, the rigid side, and then you have exosuits, which tend to be on the soft goods, fabric side of the house. They both support the body structurally so that you can do any form of endurance related activities. So things repeatedly or support the body in awkward postures like you're leaning over or you're working overhead or you're doing some form of hard, strenuous work where you could be doing something that normally we would suggest not doing, like if you're lifting a very large load or pushing and pulling something that is high in weight. These will support the body in a way so that you don't take on that risk. The system itself takes on that risk. The way we use exoskeletons at Boeing is from the industrial production side of the house. So what we look at are exoskeletons that make sense for when we're putting our workers in awkward postures. Like I mentioned, you may be kneeling, squatting, stooping, leaning over, leaning to the sides, working overhead. Over time, these tend to lead to bodily injuries or ergonomics-based injuries. And so what we look at are preventative methods to kind of weed those out and reduce the risk. So those are the postural assist systems that we call it. Then we have what we call the supernumerary arms. Essentially, if you think of like Spider-Man activities, if you remember Dr. Octopus from that science fiction genre, you have multiple arms that you can use in an assembly fashion to help hold instruments and tools that you may be working with, the parts that you're working with. And then outside of supernumerary arms, you have the strength category, where now you're talking the Herculean type situations where you're doing things that we prescribe you don't do. Essentially, you're exceeding your normal capacity of strength, or you may have that natural capacity, but we just choose to keep you safe and not have you endure that every day. And so these are things that will be moving things beyond 50 pounds, 100 pounds, up to 200 pounds. These are the categories that we call the Hulkbuster suits. They tend to be in the science fiction genre more than anything else. Yeah, so it's interesting when it comes to what inspired me to get into this field. I always like to joke around and say I'm the adopted kid in my family because not many people have had degrees. So my parents are immigrants to the United States. They came from Jamaica, and so being the first American in my family, my parents had the pressure. In fact, all of my family had the pressure imbued on me for supporting the family and coming up with bettering myself and basically raising the family up from previous standards where they came in as immigrants. And so, the bar was set at, get a degree, consider going into a field like law, medical, engineering, one of those. So growing up, I think I was around 5 or 6, and at the time we didn't have cable television, and so I spent a lot of time watching reruns on whatever was on broadcast TV, and one of those was Star Trek, and so I spent a lot of time watching the original series Star Trek, which you can probably see behind me. I always keep that in memorabilia. One of the figures that inspired me was Geordie LaForge, who was a chief engineer on the Starship Enterprise. It was almost like, how can I get to do one of those jobs? Do I need to join the Navy? Do I need to go into the military, the Air Force? And I found my ways doing that growing up in Florida. So in Florida, one of the coolest things during the 1980s and during the 1990s was getting to see space shuttle launches. And I lived on the east coast of South Florida down in an area called West Palm Beach. So we could just look north and you could see space shuttle launches as they happened. Just looks like this tiny candle just going up in a stream of smoke. And so that helped inspire me, so both the science fiction side and the nonfiction side joining together to basically say, hey, somehow I need to get into aerospace, I need to get into engineering. And that basically secured me. Jokingly aside, I also watched a lot of Indiana Jones growing up and wanting to be an archaeologist. When I found out I had to spend a lot of time essentially begging for money, looking for funding so I could go dig in dirt somewhere, I said, nah, I think I should go into a job that's a little more supportive financially. And so I ended up going into engineering. I went to the University of Central Florida in Orlando, Florida, and I did all of my degrees there from electrical engineering undergrad all the way to my PhD. Um, and so, yeah, that's essentially how I got my kick. It was watching real rockets and watching science fiction versions of spaceships. Yeah, so the advice that I would give my 11 to 14-year-old self is to stay encouraged. So one of the things that easily happens when you're pursuing the STEM field is if you're not a genius in that area, it takes a lot of passion and a lot of struggle and a lot of work to stay inspired to continue down that venture. And so you have to find something that keeps you inspired. For me, that was things like, watching science fiction, getting involved with sports, getting all these different support mechanisms to help me cope and stay the path that I was on. Um, don't be afraid to fail. Sometimes that happens. I've had that happen to me personally. One of the things I don't talk about much is I actually failed out of my undergrad when I was in college, and it took years of going back to community college and reasserting myself and building myself back up to then learn how to focus and how to synergize myself in a way that I was basically doing successful things and continuing to build on that success. So sometimes it takes a failure to basically instigate a plan of action so that you can rebuild yourself and find how you can become more successful. Once you get those different successes down, success builds on success, opportunity builds on opportunity. And so you're always looking for how to keep yourself encouraged. And sometimes that means getting some wins, but sometimes that means taking some failures. So you learn to go with both and you become a better person for it. So keep encouraged and surround yourself with the people who can keep you encouraged is what I say.
Exoskeletons, a technology that a lot of people believe for many years were a science fiction, as now they're becoming a science fact. We're still not exactly where we want to be. We're a little bit closer. There are still many challenges about this. But let's meet some of the other best and brightest from this field. Let's take a look at other types of companies and let's take a look at how they use engineering humans.
My name is Victoria Budiko. I'm an ergonomist specialized in exoskeletons, and I work for Mawashi Science and Technology, which is a company that develops exoskeletons. For the past 7 years that I've been with Mawashi, I can say that I had a typical day. A typical day in my type of work doesn't really exist. My days are determined or by scheduled activities that are in the calendar or based on emergencies that come up at the beginning of the day. So normally I open up my calendar and my chat rooms with the professionals that work with me, and I go and I verify what's going on in the workshop. So if there is any prototype, any mock-up, or anything that is ready to be tested, I do my best to test it as quickly as possible, to give feedback quickly to the team so that we can progress in the design. So the company where I work initially developed exoskeletons for the military, and they were intended to help the military carry their very heavy backpacks, because that's a real serious issue today. And with time, the exoskeletons that we developed kept on maturing and extrapolating to other technologies. So today we are developing military exoskeletons for load carriage, but also occupational exoskeletons to help workers do difficult repetitive tasks such as lifting and handling boxes or heavy bricks or heavy blocks, really manual labor, aiding manual labor workers. I think that the best skill one has for my job is to be open to knowing much about many different areas of science. So, for example, a very, very important skill is, of course, knowing the human body and being open to find out more about it as the time goes. Because even when we get out of school, even while doing our professional work, we never get saturated with knowledge about the human because it's such a beautiful machine, right? And we are creating a machine which is an exoskeleton, and learning from the human is a very important aspect of it. The other part that is extremely important is having good notions of geometry, just because whatever we're building is a three-dimensional object that moves, so understanding how it changes shape, form, how the forces react within that, that's extremely important. So I would say if I had to bring it down to, let's say, four major skills that are necessary, that would be knowledge of anatomy, physiology, knowledge of geometry, some knowledge in physics, and good communication skills. By communication, I mean verbal as much as drawing, doing mock-ups and expressing ideas in any way feasible, depending on the people you speak to. Actually, my hobbies, I think, brought me to my job. I've always been crazy about sewing. So really, sewing garments is what brought me slowly to technical garments. And then one day, in a trade show, there was a person who showed me some drawings of exoskeletons. At the time when exoskeletons didn't yet exist, they only existed on paper. And he said, well, we're making this full body exoskeleton. Do you want to join the team? And I'm like, well, you guys are quite crazy to think that a rigid object, even if you put in all the pivots and all that, you're pretty dreamy to think that a rigid object on the body will be comfortable. But yes, of course, I'm jumping into the challenge. Let's try and see what we can do with it. So sewing is what is the first hobby that brought me to exoskeletons. Working where I work, I realize every day how important is the interdisciplinary collaboration, right? Because none of the work that I do I really perform alone. Most of the work that I do it in a combined effort with engineers, biomechanical engineers, designer, conceptual artists, and communicating with these people and having some basic knowledge in different domains is extremely important to allow a cohesive group, to allow a group of different specialities develop towards a common goal. So I think that the STEM initiative and the STEM project really sees very well the future, because to address a real world problem, you need to have a very wide vision of the problem, and you have to have knowledge from all these different disciplines. So STEM really hits the nail when it comes to that. Well, I just have to say that being a woman never really stopped me to pursue my passion. And I think as long as you have the passion for something and you really strive and put the work into it, the males will listen and the males will appreciate it because it becomes helpful for them to attain their own objectives. So I think, and really being a female can be a big advantage in many times just because of the sensibility for certain aspects that we have, but we are much more open to actually listen and to almost feel, to reflect upon us what the others feel. Empathy, I think that's a good way to put it. And the empathy towards the user is so important in our work. And being a woman also allows you, gives you actually sometimes a special status that you can use, and you can get empowered from it because men will listen to you often.